Okay, here we go. More on irrational numbers, the things that drive people crazy because they're not rational. And our I can statement is I can compare and order irrational numbers and expressions that contain irrational numbers. So basically, before in the last lesson, you learned how to approximate irrational numbers. So that's one way of making sense of them. And in this particular case, we're going to learn how to compare them and order them and use them in expressions. And that's going to help us make further sense of these irrational numbers. Remember, the thing about irrational numbers that can get us confused is they're not easy for our brains. Like I know the square root of 16 is plus or minus 4. That's easy. But the square root of 19 is weird. It's just a strange number. There's nothing exactly times itself that will equal 19. So anyways, here we go. Just a quick reminder that we compare numbers with symbols like less than, greater than, or equal to. And there's other symbols that we use, but those are the main ones. And for example, just a quick reminder, 3 is less than 5, but 2 times 2 is an expression, and that expression is equal to 4. So that's kind of how we use the symbols. That's kind of how we say them. And we order numbers from least to greatest or greatest to least. That's one way we order them. There's other ways you can order numbers too, but this is the most common ways. All right, so here's the first example problem, example 1. There's only going to be 2 in this lesson. And what we have here, we have 2 expressions. Remember, an expression doesn't necessarily have an equal sign. It's just something out there that represents a number. So this is an expression, and this is an expression. And we either need to turn this into an inequality using these 2 symbols, which means one side is either greater than or less than the other, because they're unequal. That's where the term inequality comes from. Or we need to set them equal to each other if they do indeed equal the same thing. And then that would make it an equation. So we've got 2 expressions, and we're trying to compare them, greater than, less than, or the equal to. And there's a lot of different strategies for how to do this, and I just want to show you a few of mine. Okay, so first thing I do is I come up with an approximation for the square roots, or any number in there that's irrational. I come up with an approximation. Then I add the whole numbers that I have, or the fractions. There's no fractions in this case, but or any leftover numbers to that approximation. So approximately, what is the square root of 3? Well, from the last lesson, I hope you remember how to calculate, or approximate, square roots of irrational numbers. The square root of 3 is right between the square root of 1 and the square root of 4. In other words, it's going to be between 1 and 2. But notice, 3 is 2 away from 1, and it's only 1 away from 4. Because of that, I'm going to start guessing closer to 2 than I am to 1. So I'm going to start out with 1.7. I wonder what 1.7 squared is. And I'm going to do that math really quick. You may wonder, why in the world do I take the time to do this calculation in the video? Why don't I just rewrite it? Because it wouldn't be hard to do that. The point is, I want to show you how fast you can do these multiplications and how they don't have to be a problem. People don't have to roll their eyes when they have to multiply numbers. It's really not hard. It's pretty stinking easy if you know your facts. Okay, so this is slightly less than 3. Let me try 1.8 squared and see what that gets me. 1.8 times 1.8. And again, it's just not going to take me that long. It's really no big deal. 3.24. Okay, cool. So 3.24. Now, I got a pretty good approximation now. I know that the square root of 3 is approximately 1.75 because that's between 1.7 and 1.8. And 1.7 squared is less than 3, and 1.8 squared is more than 3. So I'm going to come back here, and I'm going to write 1.75 approximately plus 2. I don't know how they compare yet. I need to come up with an approximation for this and add 3 to it. So now, same deal. I got to approximate the square root of 2. To save time, I'm just going to use something that I kind of know. It's approximately, this. But I just want to double check myself. What's 1.4 squared? And just kind of triple check. And you can see that's right below 2. And so I know it's 1.45 is a good approximation. But I just can't let that slide because I've worked in the real world, and you use the square root of 2 a lot, and the actual approximation people use is 1.41 because that's closer than 1.45. It's kind of like pi. It's a real common irrational number that's needed for example, pipe fitting. If you're a pipe fitter and you have a special triangle, you're going to need to use the square root of 2 and multiply that by one of the side lengths of your triangle to know the length of the hypotenuse. And so there's all kinds of applications for these irrational numbers. But anyways, this is how I've taught you to approximate them. In real life, you'll probably put this into a calculator and get a closer approximation. But this is good enough for us now. So this gets us to 3.75. And this right here is 4.45. So right at this point, it's really clear. I mean, even if I'm off by 100th or a 10th here, it's still clear which one's larger. It's very clear that this side over here is larger. Now, that's one strategy of solving these kinds of problems. It's where you come up with your approximations, add the whole numbers to it, and see which one's larger, right? Well, another way is you can use some sound logic. I know that the difference between the square root of 3 and the square root of 2 is not going to be more than 1. I know it's going to be less than 1. And I know the difference between the addition here, the add-ins in this expression, is 1. So using that information, I can logically just look at this and tell that this one on the right is going to be greater than. However, I don't really want to encourage you guys yet to just kind of, I mean, it takes a lot of thought to be able to logically look at something and tell right away which one's larger. I'm not talking about guessing. I'm talking about knowing using logic. There's a difference. So I don't want you to go to your worksheet and just take guesses. I want you to actually do math, do the approximations, and see which one's larger, see which one's smaller. But there may be a few on there that you can just know. I mean, you can just prove it just by making some math statements. And in that case, if you're going to do that, I would like you to write out your thoughts on how you know one is larger than the other if you're not going to do the approximations. But most of us are going to just do approximations. Okay, so that's one kind of problem. The second kind of problem I want to go over with you really fast is just ordering numbers from least to greatest. And it's exactly the same thing. We've got to approximate the square root of 7. We need to approximate the square root of 8 and then divide that by 2. And then we have 2 here. I'm going to start with the square root of 7 real fast. Square root of 7. Okay, I know that's going to be between the square root of, let's see, 4 and the square root of 9, right? So it's going to be between 2 and 3, somewhere between those, because the square root of 4 is 2 plus or minus 2 plus or minus 3 for the square root of 9. But we have a difference of 3 here. We have a difference of 2 here. Because of that, I'm going to guess closer to 9 than I am, or excuse me, I'm going to guess closer to 3 than I am to 2. All right, so let's do that really quick. Let's try, I don't know. Let me think of a really good one here. Let's try 2.7. Let's see what 2.7 squared is. 49, 14, 18, 14, okay, 5. Let's see, 9, 12, okay, 7. So 2.7 squared is 7.29. That's slightly more than 7. So 2.7 is definitely on the top end of our range. I just want to make sure that 2.6 squared isn't over 7 as well. Make sure we've got a good range here. And it looks like we're fine. So 2.6 squared is 6.76. Okay, that means the square root of 7 is approximately 2.65. That makes sense. Now we've got to approximate the square root of 8, divide by 2, and then we're done. We just have to put them in order. So the square root of 8, similarly, I know the square root of 8 is going to be between the square root of 9 and the square root of 4, or between 2 and 3. But this time, I think it's going to be even closer to 3 than it is to 2, because the difference here is only 1. The difference here is pretty big. It's 4. So I'm going to guess 2.8 squared and see what that gets me. 8 times 8 is 64. 8 times 2 is 16 plus 6 is 22.
I'm sorry,
These announcements are crazy. They're just coming all the time. So 2 times 8 is 16. 2 times 2 is 4 plus 1 is 5. There we go. 4, 8, 7. Okay, so that's less than 8. So I know that this is going to be 2.85. Sorry. My mistake. The square root of 8 is approximately 2.85. But notice what happens here is not only are they asking for the square root of 8, they're also asking us for the square root of 8 divided by 2. They want to know what that is. So I know that 2.85 approximately divided by 2, gosh, that's going to be just barely more than 1. I don't even have to do that math. I know that. That's going to be really close to 1. And 1 something is definitely going to be less than 2, and it's definitely going to be less than 2.65. So my work here is done. I can just write down my answer. I don't have to do any more math than is necessary for these. So I know that the square root of 7, since it's approximately 2.65, that's going to be the largest. I know that 2 is going to come next. It's going to be in the middle. And I know that 2.85, which is what this is approximately, divided by 2 is not even going to be 2. It's going to be 1 point something. So that's going to be the very first thing in our list because it says from least to greatest. So anyways, I'm going to end this video now because it's getting kind of long. The method with these is just to use some logic, use some math, and try and figure out which one's larger or smaller. That's all we're doing here, and have fun.